Hello guys, welcome back to our new video. This is the part 2 of wait for a minute. And this is the part 2 of chapter number 9, Gravitation, class 9th. In the first video, we have covered topics like free fall, gravitation. We have derived the formula of gravitation and the formula of the free fall also. We have done weight, mass, and also we have done the small g and the big G. Also we have calculated the value of the big G. In this part 2, we are going to study about thrust and pressure, buoyancy. You have might confusion in buoyancy and buoyant force. In this video, you will be know what is buoyancy and what is buoyant force. Okay, Archimedes principle. Okay, in this video we are going to cover 1, 2 and 3 topics. Okay, and I am giving some IMP questions which can be asked in your exams. Okay, so let's start with our first topic, thrust and pressure. You might have confused in a thrust and pressure. What is thrust? Thrust. Thrust is a force which is applied perpendicular. Let's take an example. This is a surface, okay, and you are standing on it. Okay, this is the rough drawing. Okay, you are standing on the soil, so you are applying a perpendicular. Okay, let's take another example. Some might be confused with this. Let's take a pin board. This is the surface of pin board. Surface of pin board, and this is the pin. Okay, this is the pin, and when we push the pin, the perpendicular force, perpendicular means a straight force, perpendicular force is applied on the board that is known as thrust. Okay, what is the definition of thrust? A perpendicular force that is applied by an object on the other surface of a body, it is known as thrust. A perpendicular force applied by an object on the other object, it is known as thrust. And what is pressure? Pressure. A thrust in a per unit area, it's called a pressure. Thrust on a per unit area. Thrust on per unit area, it is known as pressure. Okay. Remember students, the definition of thrust and the definition of pressure. The definition of thrust, it means a perpendicular force applied by an object on the different body or an object, it is known as thrust. And the force of thrust is per unit area, it is known as pressure. So the formula of pressure is thrust upon area. Let's take an example. Okay, let's take an example of truck. You might seen that in a truck, the tires are broader than the tires of the car, because the truck have to load many tons of weight, and if the tire is the area contact of a tire is less, the pressure will increase. If the area will increase, the pressure will decrease. Okay, so that's why the tire are broader than the tires of the car. Okay, remember students, when the pressure if the pressure increase, it means the area is less, and if the pressure decrease, it means area increases. Okay, I am giving some hint. Pressure increases, area decreases. Pressure decreases, area increases. When the area is more, pressure will be less, and the pressure will be more, area will be less. Okay, remember like this: area more, pressure less, area more. Okay, so this is the definition of thrust and the pressure. Okay, here an example of is given. Example 9.6, in which, okay, this is the example 9.6, in which they have taken two box. One is put it like this perpendicularly, and second is put it like put it in the flat. Then they have said the area, length and the breadth also of this, and they have said take out the formula and which of them, A or B, which of them will apply more pressure on the surface. Okay, obviously A will be apply more pressure because the surface area of A is less. Okay, let's derivate the formula. They have said mass of block 5 kg. They have given 5 kg. Okay, then they have given the dimension. Okay, thrust. I have told you that thrust is a perpendicular, and the pressure is thrust per unit area. It is known as pressure. Thrust is F is equal to mg. Okay, F into 5 kg, and what is Z? Gravitational is 9.8 meters minus square. Okay, so we will get 49 Newton of thrust. Okay, so area of rectangle, I am writing only rectangle, L into B. Okay, so 20 into 10, both are in centimeter, so 200 centimeter, and we have to take out the meter, so 2.02 meter square. Okay, there is meter square. Okay, what is pressure? Pressure is equal to thrust upon area. What is thrust? 49, and what is area? 0.02. so what will come out when you multiply it? You will get 2450 centimeter square, 2450 meter square, and by this only you will get the answer of 2. Let's derivate quickly. Question number 2, what they have? Area. Okay, area of rectangle is equal to L into B. Area is equal to, what is 40 into 20, what is it? 800 centimeter. We have to convert it to the meter, so 0.08 meter square. What is the thrust? P. Okay, I am writing only P. Thrust upon area. Area is 0.08 and 49. You will get 6125 meters square. By A giving a pressure of 2450 and B is giving a pressure of 61 Newton. Okay, so you can easily see the A is giving more pressure than the B. Okay, so answer will be the A. Now let's move forward. What is buoyancy? What is buoyancy and what is buoyant force? Buoyant force is also known as upthrust force. Why it is known as upthrust force? Let us see quickly. Buoyancy, a upward force which is applied by a, okay, I write in the definition. buoyancy. Okay, what is buoyancy and what is buoyant force? Buoyancy, a tendency to remain on, okay, sorry, on remain on the surface of water is known as buoyancy. Let's take an example. Let think this is the surface of water. This is the surface of water, and I am putting this pen on it. Okay, I am putting this pen on it. It remains on the surface. It means buoyant force is acting on it. So, what is buoyancy? Definition of buoyancy: tendency to remain on the surface of the water. It is known as buoyancy. And what is buoyant force? Let's quickly see it. Okay, I am writing only buoyant. In the last, you have to write T, buoyant. Upward applied by buoyant force. A upward force which was applied by water on the object, it is known as buoyant force. Okay, what is the definition of buoyancy? The definition of buoyancy is a tendency to remain on the surface of water. On the surface of water, it is known as buoyancy. And what is buoyant force? Buoyant force is a force applied by a liquid on the object, which is upward force which is given by the water on the object. It is known as buoyant force. They have given an example also. There is one bucket, okay, full of water. Full of water, and you are taking a water and pushing it down. Okay. So what is buoyancy? Buoyancy will do, it will give upthrust force on the bottle. So you have to push harder and harder to keep the bottle in the water. Okay, you have to push harder and harder to keep the bottle into the water, because the buoyant force is acting on it, and the density of the bottle is very very less than the density of the water. Okay, this is known as buoyancy and buoyant force. And when you release the bottle, when you throw on the surface of the water, the bottle will remain on the surface of water. This is known as buoyancy. Okay, so you have clear in the buoyancy and buoyant force. You might a question in your mind that when we throw a piece of stone in the water, it sinks quickly, but 100 tons or 200 tons of ships are not sink. They are floating on the surface of the water. Why do they float? I am giving the answer of the question in the last of this video. And On the base of the Archimedes principle, these all the ships are invented. That's why they can float on the surface of water. So let's quickly, what is the Archimedes principle and who is the Archimedes? Okay, who is the Archimedes? Archimedes was a person who was found out the laws of. Okay, you can read this caption in which the Archimedes was a Greek scientist. He was discovered the principle. Okay, he was a Greek scientist and he has discovered a unnoticed force applied by water. Which is known as buoyancy. He was doing an experiment in his house and uh, he found out the experiment and shouting a eureka and eureka. What is mean by eureka? Eureka, it means he had found out, or it is mean I have found out, I have found out. That is the mean of eureka. He was shouting eureka eureka, that I have found out buoyancy. Okay, let's see what is Archimedes principle. Okay, I'm not writing a cursive because Archimedes principle. AP Archimedes principle is a weight of the water displaced, okay, is equal to buoyant force. On the basis of the Archimedes principle, all the ships are invented. Let's see what is the Archimedes principle. Archimedes principle said that Archimedes principle is equal to weight of a water displaced. Okay, weight of the water displaced. Let's take an example. This is the water body. This is water body and this is stone. When you throw the stone, it fall on the water and the surface area of stone is very less, only this much. It displaces the water. Okay, it displaces the water, but it was not displace the water as much to the weight of it. Okay, let's take an example. The weight of the stone is 1 kg and it was displacing a 500 gram of water. So obviously the density of water is less than the density of the stone, so it will sink. Okay, and density of water is less than the density of stone, and this is the water body. Okay, this is the water body and the big ships are floating on it. Okay, big ships are floating on it. Okay, so what they are doing, the surface area of ships are very more in number. Okay, surface area of ship is very large, and when it put it in the water body, it displays lot of water. It means the density of water is more than the density of the ship, because it is depend on the how much of the water displaced. You have seen that how the swimmers are swimming, they are displacing the water by moving their hand and their legs. You have seen that a swimmer who swims fast, they are moving their hands and legs very quickly, so they are moving so fast. Why they are moving so fast? Because their movement is also too fast, and they are displacing the water continuously in a very fast movement. They are continuously displacing the water from its main position. So from this we can conclude that the that displace Archimedes principle is equal to weight of an object, water displaced by it. Let's take an example. A stone, gram of 200, its weight is 200 gram. Okay, and it is holded by a spring balance. Holded by a spring balance. When it was not immersed in the water, its weight is 200 gram. And when it immersed, okay, when it immersed, its gram is 175 gram. It means, and when the stone is fully immersed in the water, always the when object falls on into the or on the surface of the water, it might displace some water. It is the rule of Archimedes principle. It displaces the water. Might he have displaced the water? Not take a jar and take the water in it. He have displaced the water, and the water is stored over here. Okay, when you measure the mass of the when you measure the weight of this water, it will be 25 gram. It will be 25 gram. Okay, it will be 25 gram. It means 25 gram of buoyant force is acting on this stone, but the weight of the stone is more than the buoyant force. It sink into the water. Okay, it sink into the water. So basically you have to remember that Archimedes principle is equal to weight of body weight of a displaced water by an object. Weight of displaced water by an object, it is known as Archimedes principle. Okay, if you will if you will display more number of water in a particular manner, if you will display more number of water, you can easily float on the water. Because if you displace the more number of water particle, you can be able to float on the buoyancy force will increase. If you increase the displacing the water, when a water is displaced, buoyant force is increased. Okay, so when you increasing the displacement of the water, you are continuously displacing enough by moving hand fast in the water, then the buoyant force will more on you, so you can easily float on it. Okay, here we have completed our chapter. So here the three easy topics are there. I am thinking that to make a part 3 video on only the equations. Okay, so here the end of this part 2. We have completed our chapter number 9, gravitation. Okay, we have completed the lot of topic like gravitation, universal law of gravitation. We have derived it, value of G and the SI unit of G. We have derived that, free fall, importance of the importance of the gravitation force. Then the what is free fall. We have also derived the free fall, thrust and pressure, Archimedes principles, buoyancy, buoyant force. I think we have covered 11 to 10 topics in this video. We have covered only 3 topics, but other 7 topics are covered in the previous video of part 1. So let's meet in the part 3, because here we have completed our chapter number 9. Okay, so let's meet in the part 3, here the end of the part 2.